A very important thing with writing programs is understanding the foundations of structured programming. So I'm going to do some demos here for understanding structured programming. I've created a button and I've created an output textbooks. I could have used a list box for output, but here I know that I'm only going to output one number. If I show you the button here, the button is sequence. Sequence is just a series of lines or a series of things that you want to do in order to achieve a particular type of output. Here I'm just doing this in order to accomplish the output. I've got some numbers here. Double indicates that it's got a decimal in it. Excuse me. Int indicates that it's a whole number. Int 32 indicates that it can be plus or minus 2 billion something. And we want to work with these. If you take an integer and work with a double, which is a fairly large double, and when we're talking about a fairly large one here, we're talking into the billions. So if it is working with a double, then it will promote this so that you can convert that into the double and then make a double of a into a double of the type and sorry, this is going to drive me a little bit bonkers here. Okay, there we go. So that means that the answer here is double, and it will take these two things, make them both double ultimately, and then stick them into the answer. And then I take the answer and I need to put it into the text. And since the text is string, when we say text, a string is text, and this converts it from a number into a string. Okay, so toString, convert that to a text thing, and then it will output it. So let's look at what it actually does. So we do this, and what it's doing over here is it's going to multiply these two together, and it's going to give me the answer, which basically is gross pay, but it doesn't take into consideration the overtime. So I click the button, and that's the answer. Okay, but again, it doesn't give you the overtime properly. So that's a problem, and Sequence doesn't really have a way to fix that directly. But the next item is Decision. And Decision has a way to make choices. Okay, so let me stop this for a moment. Now here I initially just had the button and I have output. We'll talk about this in a minute. So we go here into Decision. Decision has this thing where we have a double, which gives you the pay rate. Basically it's just this as it was before. I can make it exactly the same by just typing there and make it 41 just as it was before. Originally I had just copied it, but decision says I need to make a choice, and we take a look at this choice, and this choice is hours worked less than 41? Okay, that means that it's 40 or less. If it's 40 or less, then the pay rate is all they're going to get paid per hour. Okay, and that's going to be put into double answer. But if they're going to be paid based upon hours, if there's more than 40 hours, then they get paid sorry, the base pay rate for 40 hours, and then they get paid for overtime, which is the number of hours over 40, and then pay rate times an hour and a half. Okay, and so we need to know that particular thing. So we're adding that amount to the DBL answer. And I'm just going to call that answer this hours worked and this pay rate from now on, so that it's not confusing. Now, again, we're moving answer to converting it to a string and then moving it to text here. So let's take a look at this. And if I click the decision button, then we get this. Okay, and you can see it's a little more money than the sequence demo. Okay, so, and notice that those buttons are separate. But to better understand, if we wanted, we can go up here and we can change this, say for instance, to 45 hours instead of just one more hour. We can start this up, and this is what 41 hours look like. But if we click this, this is the 45 hours, and you're getting noticeable upgrade here. But obviously having to stop the program and change the hours worked in here is not a very effective way of working with the program. So let's suppose that we want to make this program a little bit more interactive. The slashes here that you see are comments, and they are not executable. Okay, so I can type anything after the slashes and that doesn't do anything. Okay, so I've changed this, and if we look at the form, there's a text box up above. And let's say that the person, I need to execute it. Let's say that the person worked 50 hours. And you can see this number is getting bigger. Let's change this to 60 hours. Click the button, and you can see this number gets bigger. We've made this so that whatever we type in here, that's the number of hours that they worked in the program. I have gone in and made this so that this is a starting value, but then it comes here, converts the number that's here, and puts it into the number of hours worked, checks the number, says, is the number less than 41? No. So if it isn't less than 31, or 41 rather, then it goes here, slices off the initial 40 hours and pays them for that pay rate, at that pay rate, sticks it into answer, and then cuts off the 40 hours there, and you're left with whatever the difference was. So at 60 hours, you're left with 20 times time and a half. Okay, pay rate times 1.5. And you add that to the answer to give you both the 40 hours and time and a half. Could you have put that in one line? Yeah, you could have. But this is a little bit clearer this way. Okay, so if the person had worked 40 hours or less, then it would have gone and done this line. If the person had worked 41 or more hours, then it goes here to the else. So if it's 40 hours or less, then it goes here, else it goes here. One choice or the other. Now, we also have this one for looping. Now there's 4 different types of loops, but they really just work the same way. They're cycling through some sort of count. How they count differs slightly, but it really is still just a count of some sort. So let's go here and look at that. The basic one is what we call a straight count for a for loop. This is typically the simplest kind of counting loop. You start off with some value. A lot of times you see this to just be x equals I or something like that, or for x equals something like, for x equals 0, for instance. It's usually fairly simple. A lot of times this thing here, which increments, and when I say increments, I mean it adds value each time through the loop automatically so that you don't have to. This says specifically x equals x plus 1. That's what we're talking about when we say increment. Okay? A lot of times you will see it represented like this. X plus plus, which simply means x equals x plus 1. But you're not limited to incrementing by 1. You can increment by 2. You could say something like x plus equals 2, and count by 2. Okay, don't think that you're limited to counting by 1 here. Now if I were to execute this, it's just going to output the value for x at that particular juncture. So it's going to count by 1, and you're going to see that. Now when I execute this, there's 2 things that are currently running, and so you'll see both of them. I don't want you to get confused over that. Here's my button for looping. Okay, so there's the count. And you can see why the list box is very good for more than one thing. Okay. Okay, so there's 3 different things that are used for counting a lot of times. You don't have to use all of them for counting, but it's just typically easier for this one, especially if you're just counting, especially if you're just counting by ones, but you don't have to use that one for ones only. You can use it to count by 2s, you can use it to count by whatever. It doesn't matter. But typically, the for loop is used to just count, and not for much of anything else. Now, the for loop is very similar to something called the while loop. And if you look at it, the part that's here first is basically a match to this line above where the while comes in. And then the part that's in the parentheses for the while is the part that is the next part here, where it says while x is less than 10. You see this one says I is less than 10 because it says I instead of x because you can't use the letter over and over again with the for loop. Okay, so I used I instead, but it could just as easily have been x. And then this part at the end here where it says x equals x plus 1, you'll see this at the end, I equals I plus 1. Again, in a while loop, you must take that and put that in here. Okay, if you don't, this loop will run unending, and getting out of it is not too easy. Okay, but otherwise, this loop is basically the same. This one says x dot toString, this one says I dot toString, but again, this is the same basic loop. And if I were to run this again, this looks very familiar. Okay, and the reason it looks very familiar is it does the same thing as the for loop. So you may be asking yourself, why would I use the while loop, or why would I use the for loop? Well, the for loop counts, and it counts very efficiently. The while loop, however, can do things that don't directly involve counting. It can take in information so that you can say, for instance, take in a name, display the letters of the name individually, do things like that. The while loop isn't limited to just dealing with counting. Okay, so that's why you might be doing that for that particular thing. But it's very important to note that the while loop does have this 3 sections that you do see on the for loop. Okay, so the for loop, the while loop, and the one I'm about to show you, which is the do while, are nearly the same. Now the do while does differ in one respect. Right off the bat, you do see that the while loop checked the value before entering the loop, whereas the do while loop doesn't check the item until it gets to the end of the loop. And that's very important, because this increment doesn't occur until you get to the end of the loop either. Okay, so let's run this. Now the output should look basically the same. Starts at 1. Okay, so the other one was going through 9. This one goes through 9. Okay? They look alike. Why would you use this one over that one, or vice versa? Well, this one again checks at the beginning. This one checks at the end. And this one arguably is better for coming inside of the loop, saying to the user, saying something to the user like enter your name, collecting the name, doing something with the name, and then checking to see how many names that have been entered, going back up and repeating the loop until, say for instance, 5 names have been entered. Okay, so it just drops out and to the next line afterward. Each of these are nuanced, and until you reach a specific point where you've been programming and you realize that you need a different loop, you probably won't be able to understand fully the differences between these. But these are all loops. Oh, I missed one. These are all loops, and these first 3 super similar. Okay? This one's going to look a lot different. This is the for each loop. And although it's similar in many ways, it does have some differences. Okay, first of all, I created strings right off the bat. I could have created numbers, but I like this one as a demonstration of the fact that this one is frequently using strings. Okay, so it's just convenient. So here's the for each loop. Okay, so it says for each string, okay, so I could have said for each name, for instance. In fact, let's see. I'd only have to change it 2 places. Okay, so said for each name in string names, as in plural, okay, so it's these 4 names, okay, then output the name. And I don't have to say .toString because these are already text. These are already strings. And notice that there is square brackets here. That indicates that there's more than one of the type string. We'll talk about that more when we get to data types next week. So when we are doing this, this extracts one of the items from the group one at a time and then outputs it. Now it does have a counter inside of it, but it doesn't have, you don't have to mess with the counter. It's internal. Okay? Keep that in mind. The counter in for each is internal. It's on the test. Remember it. Now, let's see what this looks like. Hopefully I can only press this once. There we go. Okay, so when we do this, it outputs the names, and it is very convenient for that sort of thing. Ultimately, you will have an assignment where what you'll be outputting might be, say for instance, something like the names of every capital of every state or something like that. You could have a good many of those and have to do that. Okay, so those are the 4 loops, but again, keep in mind these are the 3 structures of structured programming. Every single program uses at least one of these structures, and in all probability, the bigger the program, the likelier that you're not only going to use all 3 structures, but you're going to use groups of these 3 structures. They are like the DNA of the program. And these structures are responsible for carrying out the variations of different programs. There are millions of programs. These structures make up bits and parts of every single program. Okay, so structured programming, very, very important.